Hello, our most valued student. My name is Confident. Welcome to our revision session of grade 12. This topic mainly is based on trig applications, and it deals with solving problems in 2-dimension and 3-dimension. So in today's lesson, as I said, it is a revision session of the application of trigonometry in 2D and 3D, and there is a question that I wanted to revise with students as they prepare for their final exam. And let us look at the question that is given below, which was taken in one of the previous papers. The question reads, a pilot is flying a helicopter at point A, which is h meters directly above point D on the ground. He notices a strange object at point B. The pilot determines that the angle of depression from A to B is 30 degrees. So let us read that with the diagram below. It says a pilot is flying a helicopter. As you can see, there is the helicopter at point A, which is that point, which is h meters directly above point D. So we can see that distance there is h meters on the ground. So D is a point on the ground. He notices a strange object at point B. Now let me just look. There we go. So he notices a strange object at point B, and then says the pilot determines that the angle of depression from A to B, so the angle of depression from A to B, it is this particular angle, which is 30 degrees. He also determines that the control room at point C, so there is the control room at point C, is 3h meters from A. So the distance AC, it is 3h meters. And BAC is equal to 2x. So we have got angle BAC. You see that angle is 2x. Points B, C, and D are on the ground, as you can see with that shaded line. Shaded, the gray area shows that this is on the ground. On the horizontal plane, points B, C, and D are in the same horizontal plane. Alright, not the ground as such, but they are in the same horizontal plane, the flat. This scenario is shown in the diagram below, so that's what we're having. Let us look then at the questions that they ask with regard to that. Now 7.1, it says, in this case, determine the distance AB in terms of h. So if I can, that is 2 marks. So if I can try to make this much bigger like that. So we have this scenario and they want us to determine the distance AB in terms of h. So they want that distance AB. So let me mark that distance that they want, which is this distance AB. Now for me to be able to find distance AB, I'm going to use triangle ABD, which is this particular triangle. Now this particular triangle that I've just marked has in it a 90 degrees, as you can see there. So this is a right angled triangle, and since this one is a right angled triangle, there is a few things that I am given with this triangle. The first thing that I'm given is this particular reasoning, that we have a line like that, which is depression. So because of this angle of depression, which is 30 degrees here, that they gave me, so we have, since this is an angle of depression, this is a horizontal line, and at the same time at the ground this forms, or this will form, a horizontal line. So we'll have these two lines being parallel, and according to alternate angles, if this line is 30 degrees, therefore this is also equal to 30 degrees. And the reason being alternate angles, as you can see, these are alternate angles, making that equal to 30 degrees. Or you can alternatively say since this is a horizontal plane and this is a vertical plane, you have a 90 degrees there, which will make this angle 60 degrees. And if that angle is 60 degrees, and definitely the other angle will be 30 degrees. So whatever case, we are going to this angle will be equal to 30 degrees. So now when you have identified that part, you then have to use SOHCAHTOA to find the opposite, the adjacent side, and the hypotenuse side. So if I'm going to use, in this case, I'm going to use 30 degrees as my side. And if this is 30 degrees, this BD will be my adjacent side, which is my A, and AD in this case will be my opposite side, and AB will be my hypotenuse side. So these are the sides that I'm having in this triangle, and as I said, I'm going to use, in this case, SO, then I've got CA, and then I've got TOA. Now the question that I'm given, it says I must find or determine the distance AB in terms of H. So why am I using SOHCAHTOA? I'm using SOHCAHTOA because the moment your triangle has a 90 degrees like that, you must know that most definitely it will work, or it will use SOHCAHTOA. These are trig ratios. So whenever you're dealing with a 90 degrees, you must first think along SOHCAHTOA. So now if they want that distance, to say determine the distance AB in terms of H, so that distance AB, in this case, if I can just use again this marker to say we are looking for this distance AB. So for me to be able to find that distance AB, first things first is what am I given, so that I can identify whether to use SO or CA or TOA. Remember, S stands for sine in SO, O is opposite over hypotenuse, CAH, cos, is adjacent over hypotenuse, TOA, tan, is opposite over adjacent. So now I'm looking for the opposite side. So once I'm looking, they say determine AB. Let me just check again. The question says determine AB, not AD. Actually, it's AB. So what am I given? I'm looking for the hypotenuse side. So for me to find the hypotenuse side, you can see according to the statement, I'm looking for H. So which means 10 is out because it does not deal with H. Secondly, I am given, they say it in terms of H, so I'm given the opposite. So you can see I'm now ticking twice in SO, meaning CA is totally off. So I'm going to use SO, which is sine, in this case, sine theta is equal to opposite over hypotenuse. That's what it means. So now with that, I can now take this off. So I know that sine theta is opposite over hypotenuse. If I continue with my working, now I know my angle theta. My angle theta is 30 degrees. So I will have sine 30 is equal to, my opposite is H over my hypotenuse, in this case is what I'm looking for, which is my AB. Remember the question says determine AB in terms of H. So how do I find AB? Now you multiply, so which means sine 30 is equal to H over AB. Now you multiply by AB on both sides times AB. And then what you'll have now AB sin 30 is equal to H. So you can therefore divide by sin 30 to remain with AB over sin 30. So what you have therefore is AB is equal to H over sin 30. Now if you check with the calculator what is sin 30, you will have sine 30 is equal to 1 over 2. So which is h over 1 over 2. And if you see what is AB, what is 1 over 2, it can simplify to say, remember h is 1h, so you have got 1 over 1 over 2, and this simplifies to 2. So this is same as h divided by half. You can say h divided by 0.5. As I said, there is a 1h there, which is 2h. So AB is equal to 2h. That is what you have. You can leave it as h over sine 30. It's still fine, but this is actually the better way of doing it. So we have now our hypotenuse, in this case being equal to 2h. So that is how you solve that. If I can just write there, AB is 2h. Now the next question, it says show that the distance between the strange object at point B and the control room at point C is given by BC is equal to that. So now we are looking for the distance BC. So if I can erase what I was working on here, we already have our information to say we have proven that AB, what they wanted. Now they're saying show that the strange object at point B and the control room. So now they are looking for the distance BC, and for me to be able to find this distance BC, they say I must show that it simplifies to BC is equal to that. So I'm supposed to prove in this case that. So now let's work on how to simplify. This is 4 marks, as you can see. Let's work on how to simplify that. So what I have now is a triangle, and this particular triangle that I'm going to use will be that triangle, and which is triangle ABC. That's the triangle that I'm going to use. And in triangle ABC, what information am I given? Remember, we have AB, which we found in the previous question, which is 2h. So I have here 2h. So that's what I'm having. I've got AB being 2h, and I just want to show you something here also. So if I can just draw this triangle outside here, it's more like I've got that with that and that. So this is more like the triangle that I'm given here, and this triangle is A, B, and C. Now, if you remember the naming of triangles, the angle A, opposite is side A. For angle B, opposite is side B. And for angle C, opposite is side C. So that's what you must remember. And what am I given? Remember, I'm given 2h, I'm given 3h, and I'm looking for BC. And also there is an angle that I'm given here, which is 2x, which is very important for that. So now if what I want is that, I'm looking for A and I'm given the angle for A, then I can use, if I go to my formulas, I've got 2 formulas that usually work, which is the sine rule and the cosine rule. And in this case, if I can just check on my formulas, these are the formulas, and I have the sine rule and the cosine rule there. And in this case, what is applicable is the sine rule, and usually 4 marks, questions of 4 marks, 5 marks usually deal with the sine rule, and questions of 3 marks usually deal with the cosine. Questions of 3 marks deals with the sine rule, and questions of 4 marks usually deal with the cosine rule, 4 or 5 marks, and questions of 2 marks usually deal with trig ratios, which is SOHCAHTOA. So that is something just to look around that place. Not that it's a rule of thumb. I'm just saying usually examiners like asking such questions to say, if it's above 4 marks, just think around the cosine rule before the sine rule, and just check for signs whether it is a cosine rule or the sine rule. Now, what do I do? Look at this cosine rule. It says a squared is equal to b squared plus c squared minus 2bc cos a. So if you look at what I'm given here, you can see that this is actually looking for this cosine rule, because I'm given two sides, which is in this case 2h and 3h, and the angle surrounding those two sides. So whenever you're given that and you want the other side, cosine rule will always work. And the cosine rule says a squared is equal to b squared plus c squared minus 2bc, and this is cos A. So now if I substitute the information that I'm given, what is my a squared? My a squared in this case is bc squared is equal to b squared, which is my ac squared plus my ab squared minus 2 dot ac dot ab cos A. If you now continue to simplify, my bc squared, that's what I'm looking for, is equal to my ac squared, which is in brackets. Don't forget, you need to put that in brackets, which is 3h squared plus my ab, again in brackets, it's 2h squared minus 2 times 3h times 2h cos A, and angle A in this case is 2x. Then if I simplify that, it will be bc squared is equal to, now 3h squared is 9h squared, and the other part is 2h squared. Remember, it's 2h times 2h, which is 4h squared minus 2. If I multiply 2 times 3 times 2, those numbers, 2 times 3 is 6, 6 times 2 is 12, and then h times h is h squared cos 2x. Now if we go to the proof, the answer has to deal with cos squared. As it says h minus 25, h times square root of 25 minus 24 cos squared x. Now in my answer there that I'm having currently, I've got 2x, which means I must convert using trig identities 2x into cos squared. And if I do that, if I go to the trig identities for cos 2 alpha, as you can see, I've got 3 of them, but I must focus on the one that only remains with cos squared. Now the first one can't work because I've got sine squared. The second one also has got sine squared, so it will be the third one, which is 2 cos 2 alpha, or cos 2x is equal to 2 cos squared alpha. In this case is 2 cos squared x minus 1. That's what I'm going to use. So when I write it, it will be bc squared is equal to 9h squared. In this case, I can actually add 9h squared plus 4h squared, which is equal to 13h squared, and then I've got minus 12h squared bracket. Remember, it's 2 cos squared x minus 1, and then this is equal to 13h squared. If you open now the bracket, it's minus 12h squared, and you multiply, there is cos squared x, and then negative 12h times negative 1 is positive 12h squared. And then if you now add that and that, because it's 12h squared plus 13h squared plus 12h squared, it will be equal to 25h squared, and then it's minus, actually let me correct, this first part is 12h squared times 2, so this part is actually 24, because I'm multiplying 12 times 2 and I'm multiplying negative 12 times that. So that is what I was doing there. So it is negative 24. So this is minus 24h squared cos squared x. Now you can see that it is going in the direction of where I want it to be. And then if I continue working on that, this will be equal to, remember this is BC squared. And then if I want to find now PC will be equal to square root of 25 h squared minus 24 h squared cos squared x. And I can factorize now h squared, so it will be square root of h squared, which is 25 minus 24 cos squared x. And if I do that, that is still BC now, and BC will be equal to, now if you look at h squared times is same as square root of h squared times square root of 25 minus 24 cos squared x. And now square root of h squared is same as h square root of 25 minus 24 cos squared x, which is what they said we must prove in that case. So that is, we have proved that BC is given by that statement. So this is the 4 marks that will ensure that you get BC correctly. So as I said, this is 2D and 3D dimensions, and I just wanted to bring it across to you. Say, as you prepare for your final exam, you can actually work on practicing on such questions, as they usually are much easier if you know what you're doing and you use your formulas correctly. It is one of the areas where you don't want to lose marks. I will encourage you guys to watch again the second lesson, where I'm going to be showing you another problem, how you can continue to deal with these such 2D and 3D problems. If you have not subscribed to our channel, I will encourage you again, guys, to subscribe to our channel so that you can be notified every time there's a new video. It becomes easier if you also make sure that the notification bell is switched on, so that the YouTube will in real time, every time there's a new video, send you a message to say check out this new video. We've come to the end of our lesson. Thank you.